yeah, I also I've been asked earlier today to also share my thoughts on parallel LEDs. Well, not of my thoughts, but how you would design them, right? And let's just imagine for a second we would want to run the same board but with parallel LEDs, and that would also be possible, right? So there, this would be, I guess, even simpler. So let's think a little bit about this. Do we want to have a new one, or let's just slap it to the same board? So there, let's say we would have the same board with parallel LEDs. What would we need? We would need a larger connector, because we would have to connect every LED separately to a board like the PD LED from Multimorphic or any other LED controller. It works similar to this WS2811 chip, right? Yeah, you're right. So Cora's right. So yeah, do not run a single LED of 12 volts. That's not so good. Yeah, but basically the PD LED works similar to this chip. So it controls a lot of LEDs in parallel, and it's current controlled per LED. So it's a fixed current, and you can also do that. Let's say we want let's say 6 LEDs. So five LEDs. So we need 5 pins to drive the LED, depending on if it's driven to ground or to voltage. So you can drive LEDs in both directions usually. So it's common anode or common cathode. That's how it's called. So we need one power pin, and we need 1 pin per LED. So theoretically we could use a connector with 6 pins only. I guess in most cases you would want to use some standardized connector with 8 pins or something, depending on how you wire stuff up. But it would look like this, right? So I got 1 connector only. There's no out. It's just in. There might be an out. So you might have an input of 8 LEDs, or depending on how large your bank is, and then you have an output of the 2 or the 3 remaining LEDs here. So then you can chain those to the next board or something. But let's pretend it's simple today. And this is electronically super simple. So you got either 5 volts or ground. That depends on how you're how you're controlling your LEDs, common cathode or common anode. But let's say I think cathode is if we share common anode. That's common anode if the power pin is shared. I think it's called this way. Now I do what Dan told me earlier. I mirror this, but not the other mirroring. X. Yep. So that it looks nice. And now we just put LED, or the generic LED in here. So now we put in would I want to put them this way? No, I do not want to put them this way, right? Kind of like this. So now we got we got all those LEDs, and we got them all connected to power. And because I'm lazy, I will do it like this. Correct me if I missed them. Messed up the direction here. But basically it looks like this. So that's how you would wire them up. And that's also what we're doing here. So That's basically the schematic of parallel LEDs. That's all which is there to it, because you need no resistor and nothing, because it's current controlled by the board. Now again, we want to run like, we have to annotate them so they get numbers. And we would then have to tell KiCad what LEDs we want to use. So we got SMD LEDs, we got through-hole LEDs. So now you have to, you cannot really see it here. But now you got like a lot of different ones with different sizes. And now that's not, basically I didn't look into that too much. So now we would have to check, that's on display module, it's interesting. No. And now we would have to check like, what's called optoelectronics or something, right? Optoelectronics here. And we would have to check LEDs. And here we would have to check what we want, basically. Right. APA 102 is like SPI based. And basically what Stern does, I mean, they do not use APA 102, but I guess you could simply put them on a spike board and they probably will work. So you shift out this using the SPI protocol, and OPP can do it. I think Spike can do it, but others might as well. It's simple. I mean, with MPF you can bit bang it, but it won't look well. it will look pretty basic in most cases. Now we can see what's available here, right? So for example, 08, 05 LEDs would be something. I have no idea if it's a good idea to use one of those. I only want parts in stock, but probably those won't be very bright. So it's like those small LEDs. But that's then up to you what you want to use here, right? So you can use those, or you can use larger ones. So like that's like through hole, but I wanted SMD, right? Like something like, I don't know, 16, 15. What's that? I don't know. I'm not an expert on this, on LEDs, to be honest. I'm not an expert at all at this, but so far my boards work. But now basically you choose your LED again. You probably reuse some. And let's say we want to have, maybe let's do it differently. Let's do in stock and let's do basic stock. Okay, now we can see what I have actually on basic stock. But that's like 805, okay? But that's all the basic stock, okay? And now, we choose, I don't know, colorless LED, something. That's basically now up to you. So we can use that one, for example, and let's say we want 0805, bam. We want, Molix connector again here, Molix KK, bam. And now we're back to the board. And now if I press update from PCB again, it will basically give me some more parts here, right? And now I can, I mean, the board is full, I know, but now I can place those LEDs and basically that's it. You mean you place them somewhere, like here in the same places, and then you wire them up. It's even simpler here. In this case, there's actually no way to have like a power and a ground plane. It's simply, there's no reason for that. You put like the 5-volt plane on top and you connect all the stuff, and that's it. You have to, and if you drive parallel RGB, you have to very good with traces to not overlap. Yeah, so what I would do here, and correct me if you think I'm wrong, but I would have like a 5-volt plane on both sides. I would put this plane on both sides, but then you can still use wires and so on. So you can do like, let's put a plane here, volts, check, check, check. It will now probably complain that it's outside, right? Yeah, it's outside. It will complain, yeah. So that's probably not a good idea here. No, I can simply do a lot of another like edge, I think. Yeah, it won't be pretty here, but should have used something good. It's getting a mess here. It's becoming a mess actually. So let's move a little bit here. So bam. Okay, so I got this plane here and duplicated. Put it here again. And now we added this one. Put it on. I can use one of them. So I can use this plane and put it on top and bottom. So it's basically on both of them. This basically is a better conductor in my opinion. So if you've got the plane, there's less resistance because there's more copper. So okay, now it does. Yeah, it cannot cut it anymore. So it doesn't matter for now, right? So now I got my plane here, my ground plane, and it's automatically connected to 5 volts. They are already connected. Let's say my layout is really like it is here, right? So now if I would want to trivially route it, this goes here, this goes here, this goes here. So here you see my first problem, right? So now you probably yeah, it gets a mess. Let's do it, but now you can see it's really bad, and this one, yeah, this one it still works, right? But it's not nice. That's not how you typically would want to do it. So first you would again increase like the thickness of those wires. It's, in my opinion, it's too thin for driving currents. But instead here you would do something like, okay, this one, that's fine. We can do that. This one, it intersects all of those. So luckily we got 2 layers, and I can just press V, and now I got a wire, and now I'm on the other side. And now, since this one is like in a through-hole part, I can connect from the other side, or even I can press V again, come up again, and now I'm connected here. And now I can, yeah, nicely route this one, for example, and this one, I don't know. I want to go down, and come up again. I mean, it's a little bit of planning, and you can also do this with automated tools. So it's not that you have to do this manually. So for example, you could go here, below those, up again, bam. For example, right? And like the largest advantage here is actually that those LEDs connect to ground via copper, and this actually cools the LED, because if you have only those thin wires, this LED will actually suffer thermal damage at some point, because it simply gets too hot and there's no way to dissipate the heat. And for that reason, it's good to have like have like connection to a ground or power plane. Doesn't matter, but ideally to both. So now we got like this 5-volt plane, and it's only connected here, so we do not use the other side. So what you would typically do here is have some wires somewhere and just put wires here, right? So like this, and we do not need this one. So just have a few wires somewhere. And now we have to tell it that this one is like 5 volts. And the reason for that is that we want those two planes to be connected. Otherwise, they are separated by the epoxy, which is the board, right? And now if we root it, it will probably complain about the edges, but there shouldn't be any errors. Let's see. I have 2 errors. Okay, mail find outlines. Yeah. And now I got 5 volts on both of the boards, and it complains that it's not connected. But in general, that's fine. And yeah, what did I do here? Why it's complaining about that? Yeah, the problem is that let's just... Okay, I cannot root over. But let's do 5 volts. This one, not 5 volts. Yeah, but it should... Usually it would connect those, but... Yeah, it complains about that. But what you can see now is that we connected those 2 layers. And that's also then... Usually I would do it next to the parts I want to cool. So yeah, it's the outline is messed up now. But you can see those small holes here, and they go through and connect the 2 layers here. So here you can see the other side, and it just connects those 2 planes. And that's also good for cooling. So if you got a plane on the other side, it makes sense to allow the heat to dissipate via those wires to the other plane for cooling reasons. And yeah, that's basically a very simple board, which you can do for parallel LEDs. And with 2 layers and wires, which do not cost anything extra at JLC PCB or Seed Studio or other manufacturers. So there's also PCB Way is one of them. Yeah, I did a lot of Seed at Seed Studio earlier. They also got like a library of parts which you can choose from, but it's far smaller than the JLC PCB one. So far, everything I needed has been available at JLC PCB. So for me, that had been like a great fit. So yeah, that's basically the 2 types of boards you would build. And you can have them assembled and shipped to you in a few weeks. And then you can be proud of your boards. Important thing, you also want to add a logo here, typically. So you can import graphics here. It can do SVG, and I think it can do DXF. I think somewhere you can also have like real... not here. No, that's like if you want to have like any other graphics, like bitmaps, it's a little bit different. There's like here it's an image converter where you can convert it to a footprint, and then you can add it to the board. That's how you do that. And then you got basically a part which is similar to those mounting holes, then you can basically choose your logo here and slap it to the board. So that's basically how it's done in KiCad. And then you got a logo. That's also something to think about if you want to ever export boards and so on. It's important to have like some name on it, and ideally like some logo, some company name and product name and a version number or something, because otherwise custom thinks it's a counterfeit something, and because they cannot relate this board to any documents, and for that reason it's always important to have something like that's not rendering here, Jan's LED board V1, and you typically put this on the silk screen layer, either front or back, depends a bit like on where you want it, right? Typo, but yeah, you put this here and then it's there. You can also put this into like the copper layer. It's also possible. So I think some of the manufacturers do that, right? Yeah, that's genuine board, right? And now I put that on the front layer. Probably have to run like to refill the zones, right? What did you say? It's B to refill the boards, the zones? Yeah, that also works. And I think Fast Pinball does that on their boards. So they put like their logo in the copper layer, and then you cannot see it as well. You have to actually look for it to see it. But it's also a nice effect. But they still got like some print where they tell you what board it is, but they put their logo into the copper layer. Yeah, you can do like some art with it. So yeah, there are people doing their business cards as PCBs because it's cheap, but I usually do it like this. So what do you say? Let me scroll up. I have to check it. I have to try that now. B. Yeah, works. Nice. Yeah, I would do it like this somehow. And yeah, that's basically how you do those boards. Yeah, any opinions, questions, remarks? As you probably noted, there are people which got a lot of experience here. So like especially Dan and Cobra, they ran some boards, especially Cobra. Ran like the Cobra pin stuff with a lot of boards which are very well done. And I don't know if I think you also use KiCad, right? Like the OPP people, they also use KiCad for their layouts. Yeah, happy to hear that you learned something then, at least. I'll have one RGB LED per insert, like WS2812, or do you have like one multi RGB LED here? I mean, and yeah, generally, like if you build electronics like this, you usually run like multiple iterations. So you run like one iteration. I typically do 5, sometimes 2, but usually 5. Only 2 if the parts are really expensive, but otherwise I do 5. And then I check if it's working, and if not, then I fix it up. So then I take my soldering iron or whatever it's needed, and I fix up the mistakes I made, because for some reason, I don't know why that happens, but I make mistakes on boards. I fix them up and verify that the board is working. Then I fix the stuff in my layout or PCB, and then I run like the next iteration. And usually, most of the time, I need one prototype. Sometimes it's all right on the first try. Sometimes 1 or 2 parts are wrong. Then I fix those. And if it's a simple fix, then I run like larger numbers after that, right? And if it's like a larger fix where I'm not 100% certain, or I moved stuff around, then I will run like a new prototype. And that, then will take another 2 weeks or sometimes 3. But that's actually like the thing. So those iterations take rather long, but not as long as like years ago, where it has been like a lot of weeks. But it's nice. So in my opinion, so if you need like 3 iterations, it's like 2 months roughly. And after that, you can produce them in larger quantities. See you next time, guys. See you around. Unfortunately, I won't be at TPF, but my machine will be at TPF. So in case you will be at TPF, I will have something exciting there. So stay tuned for that. And I wish you all the best. Until then, have a great time and keep playing pinball.